Hello everyone, my name is Gopal Yadav and I'm postdoctoral fellow at Chennai Mathematical Institute in India. And first of all, I would like to thank the organizers for giving this opportunity to me present my work here. And this is based on this paper which appeared on Archive in April. And the title of talk is Communicating Multiverses in Holographic De-Sitter Braneworld. So overview of the talk is given over here. So first I will start with a very brief review of what is gauge gravity duality or holography. Then I will discuss how we can discuss holography in digital space, and then how we can construct wedge holography in digital space. And then I will discuss the application of this wedge holography in digital space to construct multiverse models. So, gauge gravity duality is a duality between strongly coupled quantum field theories in d minus 1 dimensions and weakly coupled gravitational theories in d dimensions. And for a cartoon picture of the same is shown here. So this is like we have some d-dimensional antidistributed gravity living in this bulk, and at the boundary of this geometry, we have quantum field theory in d minus 1 dimension, which is strongly coupled. So this duality is very powerful because we can compute many things in quantum field theories at a strong coupling, which was not possible because of this non-applicability of perturbation theory. And we can extract the information about quantum field theory at a strong coupling from the gravity theory in which is weakly coupled and vice versa. So in digital space, this holography was discussed by these authors as a like DS correspondence, which states that gravity in d-dimensional digital space is dual to two CFTs which are coupled to each other, and d-dimensional dimensional digital gravity at omega equal to pi r over 2 slice. So for that they consider the metric which is given over here, and this is the metric at constant omega slice. And sorry, depending upon this war factor, this bulk metric can be either anti-de-sitter or de-sitter. So for example, if we have a war factor as sin square omega over r, so this will describe de-sitter bulk. If we have war factor as sin hyperbolic square omega over r, then this will describe anti-de-sitter bulk. And there is another kind of duality which is known as ds-cft duality. Sorry. So it describes gravity in d-dimensional de-sitter space, and it relates this gravity to the safety living at the future or past boundary of the d-dimensional digital space. And wedge holography is a codimension 2 holography. So mathematically, it is described as ADS-D CFT minus 2 correspondence. And for the anti-digital bulk, this was constructed in these two papers by these authors. And for the flat space-time bulk, this was constructed in this paper. And this wedge holography has played an important role in resolving the information paradox, in particular to get the page curve. And there are many literature on this issue. And then this was used to construct multiverse model in 2023 in one paper by me, and there was another paper by Sergio and Philip in the same year, I guess in November 23. Now motivation is to construct wedge holography in digital space, and then how we can construct multiverse model in digital space. So for that, this is the bulk action. This is the action defined at the end of the whole brain. So this is the Einstein-Hilbert term with positive cosmological constant because we have digital space. And had G beta is the induced metric on end of the whole brain. Beta labels the number of end of the whole brain. So we have two, so beta equal to 1 and 2. And K beta and D beta are the trace of the extrinsic curvature and tension of the inductive branes. So for this bulk, we have Einstein equation which is given over here, and the solution is given by this. So this is the metric of the static patch. This is the metric of global de-sitter. So in this case, we can have either static patch metric or global de-sitter. Both satisfies the equation of motion. And the range of the coordinates are given over here. So if we consider two omega constant omega slices at omega equal to omega 1 and omega equal to omega 2, then we obtain the special slice of this space as shown here. So y1 and y2 are two individual branes at these locations, and the geometry on these can be either static patch or global de-sitter. So if bulk is d-dimensional, then geometry on these branes will be d minus 1 dimension, and these two are joined at this d minus 2 dimensional defect. And this heterogeneous holography has three description. One is the boundary description. that there is a d minus 2 dimensional defect CFT which is living at the corner of the wedge formed by two individual branes. And these two branes Y1 and Y2 are interacting with each other via the transparent bonding condition at this blue dot, which is defect. And bulk distinction is that CFT which living at the which is like defect of defect. This is dual to gravity living in this wedge formed by two individual branes. So because this is d minus 2 dimensional CFT, the gravity is d dimensional, so we have d is d CFT d minus 2 correspondence. So more precisely, it's like we have classical gravity in d-dimensional digital space, and this is dual to quantum gravity on two d-1 dimensional end of the branes with metric ds DC dimension because of Braneworld like holography in digital space given by Andreas Karch, and this is dual to CFT living at the d-2 dimensional defect because of DSCFT correspondence. So overall, we have DST, CFT, minus two correspondence. So in this paper, we just state this duality, but more detailed dictionary will do it later in upcoming maybe time. And for the construction of visualography, the bulk metric should satisfy the Newman bounding condition at the location of the individual brane, where in this equation, K is a beta is the extrinsic curvature, and it is defined over here. And this is trace of the extrinsic curvature. So for the given bulk de Sitter, if we compute this quantity, then we see that bulk metric satisfies Newman bounding condition provided tensor brane should be this particular form, where omega 1 and omega 2 are location of end of the brane. So if we take omega 1 to pi r over 2 slice, then we get tensionless branes. This is consistent with this paper where they discuss double holography in DC space. So this is just like mathematical construct, just following the idea of visualographic construction in ADC space-time. Now I am going to discuss another method to construct this visualography in DC space. So for that, we will discuss double holography in DS correspondence. So this was discussed in this paper, and the metric for the D plus one dimensional DC space with the extended static patch metric is given over here, and range of the coordinates are given over here. So to construct a double holography in this geometry, these authors constructed two slices, which is chi equal to pi by 2 slice. They denote it by Q, which is like Randall syndrome band, which I will call at RS band in the top. And there is another slice omega equal to pi by 2 slice, which is described by Y. So in this symmetry, Q is interacting with Y. If we compare this double holography with ADS description, then Y is like path and Q is like black hole. So, but here we have d theta space, and the Y is like UV brane. So this is like UV part of the geometry. Now, to construct wedge holography in this context, we have to glue two copies of the DSDS correspondence in double holography, what I discussed earlier. So for that, let us understood how we can construct two geometries. So for example, we have two geometries, which is like ADS-D plus 1 gravity in this one bulk, and there is ADS-D plus 1 gravity in this bulk, and we want to glue these two geometry. So for that, we put one brane over here, another brane over here, and we will glue these two geometry along these two branes. So at the end, we will obtain geometry something which is given over here. So these are like two areas T plus one glued to each other, and they are glued along this blue surface. It's like some brane. And for that, this Israeli junction conditions has to be satisfied. So description A is like just one copy of double holography where Q1 is interacting with Y1. This is another copy of a double holography in DSDS, which is like Q2 is interacting with Y2. Then we will glue A and B. So we will obtain a picture at the end of like something like D. So here we have like a space which is mounted between two RS planes Q1 and Q2. So this form a wedge holography like structure because we have two in-depth brain. Sorry, here we have RS planes. So these are glued to each other at this D minus one dimensional defect because bulk is D plus one dimensional here. So mathematically, this is the metric for the description A, where we have coordinates omega 1, chi 1, and other coordinates beta, t and beta. And in this geometry, omega 1 equal to pi by 2 slices y1, chi 1 equal to pi by 2 slices q1. Sorry, this is typo. This should be chi 1, this should be chi 2. And for the description B, we have omega 2 and chi 2, and rest of the coordinates are same as description A. So omega 2 equal to pi by 2 slices y2, chi 2 equal to pi by 2 slices q2. So this is how. So in double holography, we have space available between RS brane Q and UV brane Y. In wedge holography, we have space available between two RS brane Q1 and Q2. So now discuss parallel universes in extended static paths holography, we take multiple copies of the wedge holography. So this is like just one copy of wedge holography, this is another copy of wedge holography, and so on. So to discuss this construction, I will replace a sphere by a rectangle for the simplicity. So it's like this is one copy of wedge holography, this is another copy of wedge holography. So Pi is like building block of this setup. So here we have two RS planes Q1 and Q2. Here we have Q3 and Q4 because there is a Einstein gravity with positive cosmological constant on these planes. So these are like two universes which are glued to each other at this defect. So this form like two multiple copy of Weiser property. This form like parallel universes because they are parallel to each other. So this will exist as long as we will not glue P1 with P2, P2 with P3, P3 with P4, and so on. Otherwise, if we glue all them together, then we obtain a single de Sitter space bounded with two RS planes, not a parallel universe. And notations are given over here. So now I'm going to discuss how we can construct multiverse model in de Sitter visualography. So for this, I will take just general description which I discussed here. So, for example, yeah. So in this symmetry, we take two constant omega slices like omega equal to y1 and omega equal to omega 2. Sorry, omega equal to omega 1 and omega equal to omega 2. In general, we can take many omega slices. For example, omega equal to omega 1 to omega n. So we obtain like n slices, and there is Einstein gravity on each slice. So with positive cosmological constant, so it's like we have universe with positive cosmological constant, which are like n in number. They all are glued to each other at this common point, which is defect. So this form a multiverse like structure, and we can construct like how we can discuss how we can communicate between these multiverses. For that, we take many copy of the multiverses. So in this multiverse, we have universes as y1 to yn, and in this we have z1 to zn, and here we have x1 to xn. So as long as we do not glue these branes from one multiverse to another multiverse, we obtain a disconnected multiverses. If we glue one brane of this Y multiverse with another brane of Z multiverse, then we obtain geometry something given over here. So now we can like create a communication between these multiverses. So there is a possibility then that these all branes can be glued to these all branes. These all branes can be glued to these all branes one by one, not simultaneously. Then we obtain a single de Sitter space bounded between two RS planes. So we don't have communicating multiverses. We have just single de Sitter space. So again, so we have to be careful. So what to glue or what to not to glue. So this is summary of my talk. So we constructed visualography for the de Sitter space as a bulk theory, and we constructed a multiverse model in de Sitter visualography, and this can be used to discuss information paradox in de Sitter space, and provides DST CFT2 minus 2 correspondence. So this will shed some light on de Sitter holography, and thank you. I will see you in the discussion session.